Welcome to McPlum, simple solutions served daily.
Quantum computing uses quantum bits called qubits to process information differently than classical bits. A qubit stores information using superposition and entanglement simultaneously. The dominant model uses quantum gates that manipulate qubit states by unitary matrices. Today, many systems are NISQ hardware with about 5 to 50 qubits and imperfect gates. You must learn linear algebra, complex numbers, and probability to read quantum algorithms. Start by strengthening classical programming skills and math foundations before moving to quantum-specific tools and experiments. Begin practical work by learning Python and a quantum SDK such as Qiskit or Cirq. Practice on local state vector and noise simulators, then use cloud hardware for real runs. Classical simulators typically handle up to about 30 qubits before memory and time limits occur. Understand device metrics like gate error rates and coherence times. Superconducting qubits often show coherence times around 50 to 100 microseconds. Learn error mitigation, pulse level control, and benchmarking to evaluate noisy intermediate-scale devices. Create a portfolio showing quantum algorithm implementations like Grover, VQE, or KA on simulators and hardware. Contribute to open-source projects, submit code to Qiskit or Cirq repositories, and present at conferences. Seek internships or research positions in university labs or industry teams. Typical role titles include quantum algorithm developer, hardware engineer, and quantum software engineer. Salaries vary widely, but commonly range from 00, 000 to 00, based on experience and location. Continue reading papers and practicing experiments to stay current.
Thanks for watching. Stay juicy and subscribe.